Hey guys, today we're going to be going into lesson 2.2, which is all about powers. That is the main focus of this entire chapter. Yesterday we kind of focused more on just roots and cubes. Today we're actually going to get into how different types of exponents are going to affect the base, as well as how having a negative base will affect the power overall. Okay, so like I said, this is lesson 2.2, powers. There's two important rules to keep in mind when we're dealing with powers. The first is that any power that has an exponent of 0, that entire power will become equal to 1. So for example, 4 to the power of 0 is just 1. X to the power of 0 is just 1. So a common mistake here is to convert just the exponent into 1, but if the exponent is 0, the entire power is 1. The second rule is that any power with an exponent of 1 is equal to the base. So 4 to the power of 1 is equal to just 4. X to the power of 1 is equal to just x. This also works backwards, so any term that doesn't have an exponent actually has an imaginary 1 for an exponent. Okay? I also want to go over how to deal with negative bases. So if you have a negative base, the exponent only applies to the negative base if the base and the negative sign are in the bracket and the exponent is outside of the bracket. If that's not the case, the negative sign won't move with the base. So we'll go through a couple examples to show you what I'm talking about. Okay, so if you have negative 2 to the power of 4, what that means is that you have negative 2 times 2 times 2 times 2. So because the negative 2 is not separated from the exponent with some brackets, that negative sign only goes with the first 2. The other 3 2's do not have a negative sign with them. And so what that would end up equaling is negative 16. If, on the other hand, you have something like this, where you've now got the negative 2 in brackets and the exponent on the outside of those brackets, that means that the negative and the 2 are held together for the entire repeating multiplication. So it'd be negative 2 times negative 2 times negative 2 times negative 2, which would equal positive 16 instead. If you have something like negative 2 to the power of 3, that once again is not holding our negative sign and our 2 together. So that would be negative 2 times 2 times 2. So negative 8. Okay. Now in this case, it actually doesn't matter. As you can see, if I do one more example here, negative 2 to the power of 3, negative 2 times negative 2 times negative 2 is also negative 8. So whether or not there's a bracket or where the bracket is relative to the negative sign really only matters if our exponent is an even number. Then it will affect whether our answer is positive or negative. If our exponent is an odd number, it doesn't actually change our answer. Okay, the one other thing that I do want to kind of show you here, because you might see it, is something with a double negative sign. So something like this. If you have something like this, what that means is this negative sign just goes in front, and then you have negative 2 times negative 2 times negative 2 times negative 2. Because my negative and my 2 are getting held together for the repeated multiplication, I'm just keeping this extra negative sign out front. What I would end up having there is still my negative in front, and then 16 as an answer, which would end up as negative 16. Okay, so there's a lot of different possible scenarios based on where your negative signs and brackets are relative to one another. So just keep in mind that the use of brackets is really important, and that's true even if you're just typing this into your calculator, that it's really important to use brackets where you're supposed to have them and to not use them if you're not supposed to, because it will affect your final answer if your, whatchamacallit, exponent is even. Okay, that's it for today.